Hello, welcome back. Now we have another function that we need to find the Fourier transform. Now the new function that we have is the triangle function. Now triangle function, as the name says, is defined as, so we usually use this symbol, an inverted V. Okay, it looks like an inverted V, and triangle A of t is defined as its value is equal to a plus t divided by a square if t lies between minus a and 0. And you can see which is that portion. Now this here, this portion, the value of the function is a plus t divided by a square. Now if t is in between a and 0, which is the region, the second region here, if that is the region, then the function, the value of the triangle function is equal to a minus t divided by a square. And if t greater than a, means on the right of a, and if t less than a, minus a, towards this region, the value of the function is 0. So that is given by this modulus symbol. So mod t greater than a means that if t greater than a, or if t less than minus a, then of course we have the function value is 0. The value of the function is 0 at that range. Now this is the triangle function, and one more property, this function have another property. The property is that the area of this function is also 1. So how can you find the area? See, area of this triangle function is also 1. That is another property of this triangle. We will prove that. It's very easy thing to prove. Now we can see we have two triangles. We have two right angle triangles. Then area of the first triangle. So we will call it as A1 is equal to half base is equal to the length of the base is A times the height. The height is equal to 1 by A. So this we will get it as 1 by 2. How many such triangles are there? Similar, there are two similar triangles. So the total area is twice of that of the area of the any one of the triangles. Okay, so that is equal to 2 times a1 is equal to 2 into 1 by 2, and we will get 1. The area is 1 unit. So this is the triangle function. Now we are going to find the triangle functions is Fourier transform. What will happen to the function if we take the Fourier transform? And we are not taking the Fourier transform of triangle A of t, but in a particular case we are going to have A is equal, we are going to put A is equal to 1. So we are going to find the Fourier transform of triangle 1 of t. So finding the Fourier transform of triangle A of t is bit complicated. So for that purpose we are going to find the Fourier transform of triangle 1 of t. So we are going to redefine the function. So triangle 1 of t is equal to, so as the definition, it's 1 plus t upon 1 square, that is equal to 1 plus t, where if minus 1 less than t less than 0, and it is equal to 1 minus t if 0 less than t less than 1, and 0 otherwise if mod t greater than 1. So we redefine the function for our purpose. Now we are going to find the Fourier transform of this function, triangle 1 of t. So the Fourier transform of triangle 1 of t, that is what we are going to find. So by definition, this is equal to 1 by root 2 pi. I mentioned in the previous classes that this 1 by root 2 pi is optional. In physics we usually use this letter. In mathematics we use some other constant. In some other cases there is no constant. So this constant 1 by root 2 depends upon which subject you are dealing. Okay. Now usually we have this 1 by root 2 pi when we do physical problems, to the integral range starting from, so the limit starts from minus infinity to infinity, and our function lambda 1 of t times e raised to minus I omega t dt, and after evaluating this integral we will get another function in omega. So we are transforming a function in time to another function in omega. Now since the value of the integral is 0 for t less than minus 1 and t greater than 1, we are not going to write that, we are just writing the simplest form. This is equal to 1 by root 2 pi. Okay, now so the limits from minus 1 to 0, this value is 1 plus t into e raised to minus I omega t dt, plus we have 0 to 1. From 0 to 1 it's equal to 1 minus t e raised to minus I omega t dt. Now what we are going to do now is that we are not going to evaluate these two integrals separately, but we are trying to mix them together some way. We are trying to put them together, write them together. Okay, that is what that is our approach. So we can write it is equal to, before that, so if you have a function like a to b, you are going to find integral a to b f of x dx, we can reverse the limits. It is equal to b to a f of x dx, but at the cost of a minus sign. We need to put a minus sign. Similarly we can change the polarity of the limits. If a function is f of integral a to b f of x dx, we can change the polarity of the limits. We can put it as minus a to minus b. Now what the cost? At what cost? We need to put a minus sign wherever you find an x. So f of x will become f of minus x. Wherever you find an x, you put a minus sign before that, and dx become minus dx. So this is change. So there are two important rules in mathematics. You can reverse the limit by the cost of a minus sign. Also you can change the polarity of the limits. If that is a positive number, it can change that limits into a negative number, and vice versa. Both ways it is applicable. Now we have our function, the Fourier transform, say f of omega is equal to 1 by root 2 pi. Okay, 1 by root 2 pi is common. Now what we are going to do is that, so what is our, where are we now? First thing is I am revising the limits. So first thing is integral 0 to minus 1. What is the cost? Put a minus sign. And what is the value of the function there? It's 1 plus t. 1 plus t e raised to minus I omega t dt, plus, now we are not changing, we are not make any change on the second part. It's 1 minus t e raised to minus I omega t dt. So we reversed the limits. Now what we are going to do is we are going to apply the second rule. That the second rule we are going to apply. So 1 by root 2 pi into minus integral, so 0 to minus 1. We are changing its polarity. It becomes 0 to plus 1. What is the cost? Wherever you find a t, put a minus sign. Now I found a t, I put a minus sign before that. Now it become 1 minus t. Now e raised to minus I omega t. Here also there is a t. There also we can put a minus sign. So we will get plus I omega t, and there is a dt. There also 1 minus. Plus there is no change in the second integral. We are not changing it. E raised to minus I omega t dt. So rearranging that, we will. So this is equal to f, the Fourier transform f of omega. This is equal to 1 upon root 2 pi, and we have 2 minus there. Here is a minus, in that minus dt there is a minus, and it will become a positive, and what is remaining is 0 to 1. Then now change in that 1 minus t e raised to minus I omega t is e raised to minus I or plus, yes, plus I omega t dt. Now the second integral 0 to 1 minus t e raised to minus I omega t dt. Now you see the limits, both integrals have the same limit, 0 to 1 here, the second part also 0 to 1, and we can write it together. So this is equal to 1 by root 2 pi. Since the limits are equal, we can combine the integrals. Okay, that's what we are going to do. 0 to 1, and you can write 1 minus t, so 1 minus t e raised to I omega t plus 1 minus t e raised to minus I omega t, and we have a dt. So in both these quantities we have a 1 minus t, we can take it outside. 0 to 1 minus t, and what's remaining, we have an e raised to I omega t plus e raised to minus I omega t into dt. Now we know e raised to ix plus e raised to minus ix divided by 2 is nothing but it's equal to cos x. Now what is missing here? We are missing a 2 is missing. Now put a 2. So in order not to change the value of that quantities, we put a 2 in the numerator. Now that thing in that bracket, we can replace it with 2 times integral 0 to 1 minus t. So what is inside the bracket? Now it's cos x, cos omega t dt. So now you may think it's a lot of steps are there. Now if you have got practice, you don't need to write all these steps. So it's very easy. You got practice, you get familiar with these ideas, then you don't need to write all these steps. Automatically you can skip many steps. So this is equal to, you take the 2 outside, 2 by root 2 pi, and now we have an integral with 1 minus t and cos t. You apply the UV rule. That is equal to first function. You take 1 minus t as a first function into integral of second. Integral of cos omega t is sin omega t divided by omega, and the limits starts from 0 to 1 minus integral of derivative of 1 minus t is minus 1 into again integral of cos omega t sin omega t divided by omega. Now if you look carefully, the value of that first part, when you put the limit, put t is equal to 1, the upper limit, when you substitute the upper limit, that whole thing will be 0. When you put the lower limit, you have sin 0, again 0. Now the first part will be 0. Okay, now we are left with the second part. So this is equal to this is equal to 2 by root 2 pi. We can write it as root 2 by pi, no problem. Then you have integral 0 to 1 sin omega t upon omega. Now it's very simple. This is equal to root 2 by pi. Integral sin omega t minus cos omega. You put a minus sign, minus cos omega t divided by omega, and now there is an omega. Already there is an omega, omega square, and the limits goes from 0 to 1. Now apply the limits. 0 root 2 by pi. We take that omega square also, 1 by omega square into root 2 by pi. Then cos omega, put upper limit, put t is equal to 1, cos omega minus lower limit cos 0. So this is equal to minus 1 by omega square into root 2 by pi cos omega minus 1. So take that minus into the bracket, and we will get root 2 by pi 1 minus cos omega divided by omega square. Now we are going to change that cos omega. Now we know cos 2 theta. We know what is cos 2 theta. It is equal to 1 minus 2 sin square theta. Then what is cos theta? So that is equal to 1 minus 2 sin square theta divided by 2. So substituting that, this is equal to root 2 by pi 1 minus 2 sin square theta, 1 minus 1 plus 2 sin square theta by 2. So 1 and 1 will become 0. 1 minus 1 is equal to 0. Then we are left with, of course, there is an omega square also. 1 omega square is also root 2 by pi 2 sin square is not theta. Oh, it's omega. Yes, sin square omega divided by 2 divided by omega square. So there is a 2 there. Okay, you can. So let me check the final answer. The final answer is why is that like this? The answer is 1 upon root 2 by 1 root 2 by pi root 2 by. Is there any problem here? Let me check. Okay, just a moment. Okay, I think nothing is wrong. Now we have the answer. This is equal to root 2 by pi into 2 sin square omega by 2 divided by omega square. That is the final answer. Now this answer that we can convert it into the sinc function that I explained in the last class. We know sin x by x. If this is the form, if we have a function like this, this is equal to sinc function, sin c of x, sinc function. So we can rearrange our answer. We got the answer as root 2 by pi 2 sin square omega t divided by omega square. That is, our answer is root 2 by pi into 2 sin square omega by 2 divided by omega. So divided by omega square. Is omega square is there? Yes, omega square is there. So we know sin x by x the whole square. What we need, what is missing? If we have a 4 here, okay, if we have a 4 here, okay, then that thing will be equal to sinc function. So we put a 4 in the denominator of omega square. So in order not to change the value, we put a 4 in the numerator. So this is equal to root 2 by pi into 2 by 4 is 1 by 2 into sine square c of omega by 2. So why is that? Because sine omega by 2 divided by omega by 2, that is equal to sin omega by 2 or sine c of omega by 2. So we have that square of the whole thing is there. So we have the sine square c omega by 2. Now we can again rearrange it and we will get a final form. So that that 2 in the denominator. So we have root 2 upon root pi into sine c square omega by 2 divided by, there is a 2, that 2 can be written as root 2 into root 2. So one root 2 and another root 2 will cancel and we will get a final answer. That's a very final sine square omega by 2 divided by root 2 pi. Okay, this is the final answer. So this is the Fourier transform of the triangle function, triangle 1 of t. Okay, next time. Okay, thank you for watching. Next time we will come with another problem, and thank you for watching.